All right, so we're still in our quadrilateral unit, day 4, properties of rectangle. So rectangle is classified as a parallelogram. Remember we looked at yesterday, we said because my opposite angles are going to be congruent when I have 90-degree corners, which is a rectangle, right? We said it is a parallelogram. So every rectangle you'll ever meet is a parallelogram, so that means it's going to have all of those parallelogram properties, meaning my opposite sides will be parallel and congruent. My opposite angles will be congruent. My consecutive angles will be supplementary. And my diagonals will bisect each other. Okay? So all of that from our properties of parallelograms will still hold true for our rectangles. Okay? So it's not necessarily just the 90-degree angles. In addition to these parallelogram properties, in a rectangle, my consecutive sides are, do we remember this symbol? Perpendicular. If you didn't remember that, then next to the symbol, you need to write that down. Consecutive sides, remember, are sides that are next to each other, right? Like consecutive angles are angles on the same side, so they're angles that are one right after the other. Same thing with consecutive sides. If I'm looking at this side, there's two sides that are consecutive to this one, and that's going to be the two that touch it. So for example, if I just refer to the one below, those two sides will be perpendicular because they're consecutive. They're next to each other. Okay? And if they're perpendicular, I know that means that the angles are 90 degrees. Or you could think of them as right. Okay? And with all the other properties, we know that if these two are consecutive, then this one would also be right, which makes sense because those have to be supplementary. And then these two are consecutive, so this one is right, which makes sense because the opposite angles have to equal each other. And then these two are consecutive, so they're perpendicular, which means they're also right. So that's how we get our 4 90-degree angles in the corner of our rectangles. Okay? The second property we need to know is one that we probably haven't learned before, but it is that diagonals are congruent. So remember we said that's not necessarily true for parallelograms, but in a rectangle that will be true. Okay, so if I draw in my two diagonals, pretend that's a straight segment, I know that those two diagonals are bisected, which means I know that however long this one is, this one's the same length, and then however long this piece is, this one was the same. And with a parallelogram, I always did it like that, and I said that the two diagonals don't have to equal each other, so these might not be the same length as these, but since in a rectangle they do equal each other, let's say this is 20, so each of these would be 10. If this one's 20, this one also has to be 20, which means each of these would also be 10. So all 4 of those pieces in a rectangle will be congruent. All 4 of those pieces in a rectangle will be congruent. Make this a little darker. And perhaps a little straighter. So these will all be the same size. And again, that only happens in a rectangle. That only happens in a rectangle. That doesn't happen in your everyday parallelogram. Okay? All right, so we're going to have a lot of problems like this one here that we see on number 1. Quadrilateral RSTU is a rectangle with diagonals intersecting at V. If the distance from R to T is 2x plus 13, and the distance from U to S is 4x minus 1, find the distance from U to S. So the very first thing I'm going to do is I'm going to sketch that picture. okay? This is where we, a lot of times, will tend to go wrong, is in sketching this picture. When we draw a rectangle, when we label it, order is important. You pick a corner to put your first letter in, R, and then you have to walk around and not fall off into the lava, right? We've talked about that. So we have to go with, for S, we either have to go over here to the right or we have to go straight down. We can't put our S diagonal across over here. If it goes R and then S, S has to be either here or here. I usually go clockwise. Let me put my S there. And then for my T, you cannot put T over here. If you put T over here, you will get these problems wrong. You have to walk around the figure. So if I go RS, T has to go underneath the S. And then U will go over there. Okay? It says my diagonals intersect at V, so I'm going to sketch in my diagonals. 1 and 2, and those intersect at V. Okay? Then R to T is 2x plus 13. So R to T, that's the whole diagonal, is 2x plus 13. And U to S, so U to S, that's the whole other diagonal, is 4x minus 1. The whole thing. What do we know about those two diagonals? Yeah, they're congruent. That means they have equal measures. So I know that the distance from R to T will be equal to the distance from U to S. And then I can do my substitution. RT is 2x plus 13. And US is 4x minus 1. What do I do first to solve? Add 1 to both sides. Addition property of equality is going to give me 2x equals 4x. Or sorry, 2x, I missed something. I missed plus 14. 2x plus 14 equals 4x. Then what? Subtract 2x. So 14 equals 2x. Then what? Divide by 2. Division property of equality. And x equals 7. And then I'm ready to go on to number 2, right? Yes or no? No, why not? I'm trying to find US. So make sure you're paying attention to what you're trying to find. Okay? I'm trying to find US. I'm trying to find, let's find us. Okay? So US, we know, is 4x minus 1. And x is, we found to be 7. So US equals 4 times 7 is 28 minus 1. And we don't know what our units are, so we can just say units. 27 units. If you want to check your work, you can plug it in here also. 2 times 7 is 14, and 14 plus 13 is also 27, right? Because those two diagonals should be equal to each other. So you can check your work that way. Questions on number 1? Okay, let's look at number 2. Quadrilateral JKLM is a rectangle with diagonals intersecting at N. If the measure of angle MJL is 2x plus 4, and the measure of angle KJL is 3x plus 1, find the measure of angle KJL. Okay, so again, I'm going to sketch my rectangle. And I'm going to pick a corner to start in. I usually do the top left, and then I usually go clockwise. J, okay. JKLM, so JK, L cannot go diagonal, it has to go straight down. L, M. With diagonals intersecting at N. Diagonal, diagonal, intersecting at N. If angle MJL is 2x plus 4, so let's see where MJL MJL is, here's MJL. So that's that underneath part of that angle, is 2x plus 4. And then KJL, so that's that top piece of that angle, is 3x plus 1. We want to find KJL, so find that angle on top, which means I need to find x in order to be able to do that. Okay? What do you think we're going to do with our two expressions? Set them equal to each other because diagonals bisect the angles, right? Diagonals bisect the angles? Yes? So if I have this rectangle right here, and I draw in the diagonal, these two angles are both 45 degrees? No, I never said diagonals do anything to an angle. Those two angles are not equal to each other. But how many degrees are in that corner? 90. So those two angles don't equal each other, but they are complementary. They do have to make 90 degrees together. So how can I get my solution for x?
2x plus 4 plus 3x plus 1 equals 9.
2x plus 4, that first angle, plus 3x plus 1, the second angle, together make the whole corner, which we know is 90 degrees. We don't know that those angles are equal to each other. They could be, and if they are, then we want to call it something other than a rectangle. We'll talk about that tomorrow. But in most rectangles, they're not going to equal each other. Okay? How many x's do I have when I combine my like terms? 5. How many constants? Also 5. What do I do next? Subtract 5. 5x equals 85. Then divide by 5. And x equals 17. Okay, so again, that's not my answer, right? Because they're trying to find the measure of angle KJL. The measure of angle KJL is right here, 3x plus 1. X is 17. 3 times 17? 51. Plus 1? And it's an angle, so I'm not going to say units. I know what the units on angles are. What are my units? Degrees. If this angle is 51 degrees, how big does the other one have to be? 90 subtract the 51, or 52, and we end up with 38, right? So 2 times 17 is 34, and 34 plus 4 is 38, so it works out, right? So again, you can always check your work and see if you're getting the correct answers. All right, questions on number 2? All right, let's go look at number 3. All right, number 3, quadrilateral ABCD is a rectangle with diagonals intersecting at E. If AE equals 3x plus 3 and EC equals 5x minus 15, find AC. All right, so let's sketch our picture. Quadrilateral ABCD. A, B, C, D. You have to walk around it like it's lava. Diagonals intersect at E. E. A to E, so let's make sure we see where that is. A to E is this piece here, is 3x plus 3. E to C is 5x minus 15. Find AC. I want to find the whole length. What am I going to do? Add them together. 3x plus 3 plus so this angle, or this segment, sorry, plus 5x minus 15. If I'm adding them together, they have to equal something so that I can solve for x. What do they equal? No, they can't equal 180 or 90, or those are all angles. Huh? Oh, they equal each other. We will eventually have to add them together, but we need to know how long they are first before we can add them together, right? So I have no idea what these add to. If I did, I wouldn't have to do this problem because I would have already found AC, right? I don't know what they add together to make. That's the whole point of the problem, is to figure that out. But I do know that not because it's a rectangle, but because it's a parallelogram, I know that this piece is equal to this piece, right? Because my diagonals are bisected. So those two pieces have to equal each other. What do I do first? Add 15? Oops, those cancel, not those. All right, so I end up with 3x plus 18 equals 5x. Then what? Subtract 3x. Subtraction property of equality, 18 equals 2x. Then what? Divide by 2. X equals? Now this says find AC, so I just need to know how long are those two pieces so that I can figure out how long AC is. 3 times x plus 3, x is 9. 3 times 9 plus 3. This better also be 30. 5 times 9 is
45.
Minus 15?
30.
Huh. How long is AC? 60 units. How long is DE?
30.
30. How long is EB?
30.
How long is DB? 60. Yeah. Okay. If I wanted to, this is just kind of an extension problem. Let's say I wanted to know how long BC was in this problem. If I wanted to know how long BC was, so if I have an x here, and I know that this is 30, or sorry, 60, right, the whole diagonal. Could I find x, do you think? I probably need more information, right? What if I knew how big one of these angles was? Let's say this angle was 25. Then could I? How? Trig. So don't forget that. That might be important, right? That might be important. Okay. So now, let's look at number 4. Quadrilateral Wxyz is a rectangle with diagonals intersecting at V. Let me sketch that. Quadrilateral Wxyz. Start in one corner W and walk around X, Y, Z. Diagonals intersecting at V. V, as in vacation. Angle XWY. XWY, so that's that top piece of the angle, is x plus 3. And YWZ, so that's that bottom piece of that same corner, is x plus 15. Find XWY, so that top angle. What am I going to do? Add them together to equal how much? 90. Very good. So x plus 3 plus x plus 15 equals 90. Combine like terms, how many x's? How many constants?
18.
Then what do we do? Subtraction property of equality. 2x equals. Then what?
Divide by 2.
Division property of equality. X equals 36. That's not my answer though, right? We're trying to find angle XYW, or sorry, yeah, XWY, I can read, which is my x plus 3. So how big is the measure of angle XWY? Right, it's going to be that 36 plus the 3, which we know is 39 degrees. It's degrees because it's an angle. 39 degrees. Which means the other angle has to be 51, right? So that my 39 and my 51 make 90. So if I were to put in 36 plus 15, that would give me my 51. Okay? Questions on 4? Thank you. All right, number 5. Quadrilateral CDEF is a rectangle with diagonals intersecting at G. CDEF, like you're walking around the figure. Diagonals intersecting at G. DG is 7x minus 2. CE is 12x plus 6. Find DF. I erased it and drawing it back. Find the whole uphill diagonal. Any ideas on this one? Set them equal to each other. Multiply one of them by 2. Do you just get to pick any one of them, or does it matter which one? The one that's just half, right? This one has to be multiplied by 2 because it takes 2 of them to make one diagonal, right? So I'm going to multiply the half diagonal by 2 so it becomes a whole diagonal. So I'm going to have 14x minus 4 equals 12x plus 6. What am I going to do? Add 4. $14x equals 12x plus 10. Then what? Subtraction property of equality. 2x equals 10. Then division property of equality. X equals. And then it asks me to find DF. It didn't give me an expression for DF. So where can I plug X in to figure out what DF is? CE, right? Because DF is a diagonal and CE is a diagonal, and they're going to equal each other. So it's a rectangle, which means the two diagonals equal each other. So that means DF is going to equal by substitution 12x plus 6. Oops, I forgot my x. So that's going to be 12 times 5 plus 6, which is 12 times 5 plus 6, 66. We don't know what the units are, so I'm just going to say unit. Which means half of it should come out to 33, right? If I put 7 times 5, that's 35. 35 minus 2 is 33, so my half diagonal is 33. The whole diagonal is 66. Questions on 5? Okay. Solve the rectangle, and then I put what that means, because we haven't really used that sort of vocabulary. Solve a shape. What does it mean to solve a shape? It just means to find everything out possible about that shape. So find all the angles, find all the sides. Okay? Let's tackle the angles first, because I see one angle there that's 120. that gives me a lot of information. Because since I know my diagonals are all congruent, we really make 4 little isosceles triangles. Would you agree? That this triangle right here is really an isosceles triangle, which means I have congruent base angles. If this top angle is 120 and those 2 bottom angles have to be equal to each other, out of 180 degrees, I've already used 120 here, so what's left for those bottom 2 angles? 60, and then when I divide it into those bottom 2 angles, they're each 30. And then if we think about vertical angles, if this angle is 120, what does the one on top of it have to be? Which means what do these 2 angles have to be? 30. Because that's also an isosceles triangle, right? These 2 triangles are the same by side angle side. So now I only have 4 angles left. I have these 2 angles here and I have these 2 angles over. Oh, I have these 2 angles in here. So I actually have 6 angles left. Okay. If this is 30, how big does this have to be? 60, so it makes that whole corner 90, right? If this is 30, this one has to be 60. If this one's 30, this one has to be 60. If this one's 30, this one has to be 60. And then there's a couple different ways I could find out these 2 angles. I could either use the idea of a linear pair. These have to add up to 180, right? So what does this have to be? 60. Or I could use this triangle and say, well, if I've used 60 here and 60 here, I've used 120. So that means there's 60 left for here. So multiple ways to get that. And then my vertical angle would be over here. So we found all the angles. We're halfway solved. Now we just need to find all the side lengths. Okay? So to find my side lengths, well, first thing I notice, well, I know I have isosceles triangles, right? And I know all of these pieces are the same. And I know I could use trig because I have this 60-degree angle, but before I even go there, I notice I have a triangle that's 60 degrees, 60 degrees, 60 degrees. What does that mean about its sides if all its angles are the same? Oh, the sides are the same. So that means this is 5, and this is 5, and this is 5, and this is 5. All the sides are 5. Okay? And then I know it's a parallelogram, so my opposite sides are parallel and what? Parallel and opposite sides are parallel and congruent, right? Opposite sides parallel and congruent. So I know if this side is 5, then this side is 5. So now all I need is the length of that rectangle, right? I've got everything but this piece right here. But if I just look at half of that rectangle, I'm going to resketch it smaller. I have 5 inches here. I have 5 plus 5, so I have 10 inches here. It's a right triangle, which means I could use Pythagorean theorem. I also know that this angle here is 60, and I know this angle here is 30, so I could use trig or special rights. So to find the length, I've got options. I've got Pythagorean theorem, I've got trig, I've got special rights. Because I don't want to get my calculator out because I'm lazy, I'm going to use special rights because I know in a special right I've got a short leg, which I doubled to get my hypotenuse, right? 5 times 2 is 10, doubled to get my hypotenuse. And then I know my long leg is just that short leg times the square root of, is it 2 or 3 for a 30, 60, 90? 3. 45, 45, 90 is your 2. 30, 60, 90 is your square root of 3. If this didn't turn out to be a 30, 60, 90, it only did because that was a 120 there. If that wasn't a 120, I'd have gotten all different angles if this was a different number here. I'd have had to have used probably trig, because if this wasn't 120, this would not have been equilateral, so I would have had to find my diagonals here. Instead of just knowing they were both 5, I'd have had to use trig to find the hypotenuse and trig to find the long leg using that adjacent side. Okay? All right, I do have one more question here. It does still say to find its area. So let's do that real quick. Area of a parallelogram, what's my formula?
Base times height.
base times height. The 1/2 is for the triangle. So my base is 5 square roots of 3. I didn't label it up here. Uh-oh. My base is 5 square roots of 3. What's my height? 5. All right, my base is 5 square roots of 3. My height is 5. If I don't want to get a calculator out, then I just multiply those coefficients together. 5 times 5, square roots of 3. Inches squared. And that's the exact answer. If it asked me for exact, that would be it. If I had used Pythagorean theorem or trig, I'd have probably had a decimal here instead of 5 square roots of 3. I'd have had a rounded decimal. And then it means I would have used a rounded decimal here and gotten a new number for here that I would have then again rounded. So I'd have like double rounding. So it'd be a little less accurate than by using my special rights. Any questions? All right, your assignment's available in Schoology.